Imagine opening a doorway inside your own mind, one that dissolves your sense of self, distorts time, and floods your awareness with vivid colors, emotions, and insights. Psychedelics, like psilocybin from magic mushrooms, LSD, or DMT, do just that. Far from mere hallucinogens, they profoundly alter consciousness by disrupting the brain's normal filtering systems, unbinding rigid patterns of thought, and unlocking neural pathways usually hidden from conscious awareness. At first glance, a psychedelic experience might appear like a dream or delusion, but neuroscience reveals it is much more than mental chaos. These substances trigger organized changes in brain activity that correlate with deep emotional breakthroughs, heightened sensory perception, and sometimes even lasting psychological healing. Underneath the kaleidoscopic visuals lies a core mechanism, the temporary reorganization of brain networks, particularly the default mode network, DMN, which is linked to ego, self-reflection, and habitual thought. So how exactly do psychedelics shift consciousness? The answer lies in their action on serotonin receptors, especially the 5-HT2A receptor. When compounds like psilocybin or LSD bind to these receptors, they amplify signal transmission in the cortex, especially in higher-order areas involved in cognition, meaning-making, and emotion. But unlike stimulants, psychedelics do not just increase activity, they change how different regions communicate. Functional MRI studies show that under psychedelics, the brain becomes hyperconnected, with regions that normally operate separately now engaging in rich, flexible dialogues. Imagine a tightly organized office suddenly turning into an open brainstorming session where every department freely shares ideas. That is what happens in the brain. The structured hierarchy of networks gives way to a fluid, interconnected whole. This is why users report synesthesia, hearing colors, seeing sounds, new insights, or spiritual revelations. The brain is no longer filtering sensory and cognitive data according to the normal rules. Which networks are most involved? The default mode network, active during introspection and self-referential thought, becomes quiet. This underlies the experience of ego dissolution, where users feel a loss of individual identity and a sense of merging with the universe. Simultaneously, the salience network and executive control networks reconfigure, leading to enhanced emotional salience and a loosening of cognitive rigidity. This brain state is sometimes called entropy, or the anarchic brain, not random but unusually free from constraints. But how do these altered states translate into long-term psychological change? Recent studies in psychedelic-assisted therapy show that just one guided session with psilocybin can reduce symptoms of depression, anxiety, and PTSD for weeks or months. Why? Because psychedelics temporarily break down maladaptive patterns, rumination, fear responses, trauma loops, and allow the brain to relearn in a more flexible and open state. This has been compared to rebooting the brain's operating system, creating a window for neuroplasticity and emotional reprocessing. The visual hallucinations, too, are not mere tricks of perception. They reflect increased excitability in the visual cortex and crosstalk between visual and emotional centers. Under psychedelics, users often describe seeing archetypal imagery, sacred geometry, or even revisiting childhood memories, all vivid evidence of the brain processing deep layers of stored experience, emotion, and meaning. However, the outcome depends heavily on set and setting, that is, your mental state and physical environment. In a safe, supportive space, psychedelics can promote healing and insight, but in chaotic or fearful contexts, they may trigger confusion or psychological distress. Integration afterward is key. The altered state alone is not enough. It is how we reflect on and incorporate the experience that leads to growth. Emerging tools like EEG, MEG, and AI-assisted neuroimaging are now being used to map these states in real time. Psychedelics are becoming a lens through which to study the neural correlates of consciousness, what consciousness is, how it can shift, and how it might be expanded or reshaped. They offer a new paradigm, not only in mental health, but in understanding the very architecture of the mind. Ultimately, psychedelics reveal that consciousness is not fixed, but dynamic, a process that can be modulated, explored, and transformed. They challenge us to rethink the boundaries of the self, the brain, and reality itself. Could unlocking altered states be a key to treating mental illness, enhancing creativity, or even understanding the nature of awareness? The growing body of research suggests that the brain on psychedelics does not merely hallucinate, it reconnects, rewires, and remembers what it means to be deeply, vividly conscious. Psychedelics are psychoactive compounds that profoundly alter perception, emotion, and cognition, primarily by acting on serotonin receptors in the brain, especially the 5-HT2A subtype, and include natural compounds like psilocybin from magic mushrooms and DMT, as well as synthetic ones like LSD. By mimicking serotonin, these substances disrupt normal signaling patterns, leading to increased neural entropy and altered states of consciousness. For example, psilocybin binds to 5-HT2A receptors in the prefrontal cortex, enhancing excitability and crosstalk between brain regions, and it's like replacing a city's traffic signals with strobe lights. Drivers start improvising paths, creating both chaos and unexpected shortcuts. The default mode network, DMN, a brain system linked to self-referential thought and the ego, shows decreased activity under psychedelics, which correlates with feelings of ego dissolution and normally acts as a hub for introspection, autobiographical memory, and the internal narrative of the self. Psychedelics weaken this network, allowing less dominant brain regions to communicate freely, as seen in fMRI scans of individuals under LSD, showing significantly reduced DMN activity alongside increased global connect. And it's like turning off the CEO's microphone during a board meeting. Suddenly, everyone else starts speaking and new ideas emerge. Psychedelics increase the entropy of brain activity, meaning the brain enters a more variable and less predictable state, often linked with creative and visionary experiences. And this high entropy state contrasts with the low entropy, constrained patterns seen during ordinary wakefulness or under anesthesia, expanding the brain's dynamic repertoire by allowing previously unrelated areas to form novel connections. For example, Meg's studies show elevated signal diversity under psychedelics compared to normal waking states. And it's like jazz improvisation replacing a rigid musical score. The result is unpredictable, but rich with new harmonies. Psychedelics often produce synesthesia, where stimulation of one sensory pathway leads to automatic, involuntary experiences in a second pathway due to temporary rewiring of sensory processing circuits and breakdown of hierarchical information flow in the cortex, making the boundaries between sensory modalities porous and creating richly multimodal experiences. LSD users frequently report colorful visual patterns triggered by music, reflecting cross-activation of auditory and visual cortices, and it's like your brain's senses are attending a masquerade ball. Sight wears sounds mask and touch speaks in colors. Psychedelics dramatically alter the brain's perception of time, often making moments feel infinitely long or compressed into a singular experience. Through changes in neural oscillations and disrupted integration of sensory input over time, reflecting the brain's weakened ability to synchronize information and contributing to the feeling of timelessness or eternity. For example, DMT users frequently report experiencing entire lifetimes within minutes of real time due to accelerated or fragmented internal perception, and it's like watching a movie where the frames are shuffled, slowed down, and looped. Time becomes a flexible illusion. Many users report intense mystical and transpersonal experiences under psychedelics, such as unity with all life, encounters with divine entities, or dissolution of time and space, which correlate with peak 5-HT2A receptor activation and are associated with long-term positive psychological outcomes. Scientists hypothesize these transpersonal states arise from reduced modularity and increased integration of normally segregated brain networks, as measured by validated scales like the MEQ-30 that predict therapeutic benefit in depression and anxiety. And it's like taking a microscope to your own consciousness, then watching the lens dissolve as you become the universe observing itself. Beyond temporary perceptual changes, psychedelics have shown promise in treating mental health conditions by inducing neuroplasticity and altering entrenched neural pathways, with clinical trials demonstrating sustained reductions in depression, PTSD, and addiction after guided psychedelic therapy sessions linked to increased openness, emotional flexibility, and rewiring of maladaptive brain circuits. For example, a 2020 Johns Hopkins study found that a single high-dose psilocybin session led to significant depression relief in 71% of participants after 4 weeks, and it's like rebooting a frozen computer. Suddenly, programs can run smoothly again after years of lag. Despite their potential, psychedelics carry risks such as psychological distress, bad trips, or triggering latent psychiatric disorders, and their historical association with counterculture and strict legal restrictions have hindered research and clinical adoption. Modern clinical protocols mitigate these risks through preparatory counseling, medical screening, and post-experience integration therapy to minimize harm. And it's like handling nuclear energy. You can power cities or cause meltdown depending on how you structure the control systems. Psychedelics offer a unique experimental tool to probe the neural correlates of consciousness by dismantling and reassembling the sense of self and world, allowing researchers to observe how changes in connectivity, entropy, and receptor activation produce altered states and map the landscape of conscious experience. Future studies, such as those at the Imperial College London Psychedelic Research Centre using fMRI and MEG to create dynamic maps of consciousness under DMT, will combine psychedelics with real-time neuroimaging, computational modeling, and AI to decode the brain's most profound mysteries, and it's like giving scientists a flashlight to explore the hidden caves of the mind, illuminating corners that were always there but never seen.